Welcome to the LMWC Learning Mathematics with Ms. Choekyi channel. Please do hit the like button and subscribe the channel.
Hello everyone. So today we are going to go through the examples of the polynomial chapter. So in the first question we are given few graphs, and in each of the graph you can see various polynomials, and we have to find out the number of zeros by looking at this graph. So in the first question you can find that the graph touches the x-axis over here. So the number of times the graph touches this x-axis is only one time. So the number of 0 in the first question is 1. And for the second graph, we can find that the graph touches the x-axis over here, as well as it touches the x-axis over here. So in total, it touches the x-axis at 2 points. So therefore, number of 0 in the second question is 2. For the third question, we find that it touches the x-axis over here, and over here, and over here. So it touches the x-axis at 3 times, at 3 different times. So therefore, number of 0 is 3. For the fourth question, it touches the x-axis over here. So therefore, number of 0 in the fourth graph is 1. So again, in the fifth question, we find that this parabola, it touches the x-axis over here. So therefore, the number of 0 is 1. So at the last, we find that the graph touches the x-axis over here, over here, over here, and over here. So in total, the number of 0 is 4 in this graph. So the second question, we have to find the 0 of this quadratic polynomial, and after finding out the zeros, we have to find the relation between the zeros and the coefficients. So we are going to use the middle term split to find out the 0 of this quadratic polynomial. So in the middle term, I can find the coefficient as positive 7. So I am going to split this positive 7 into two numbers, which if I add or subtract, I have to get plus 7. And the same two number, if I take the product, I have to get the product of this 10 and the coefficient of x squared. So which is 10 times 1 is 10. So I can think of positive 5 and positive 2. And therefore, I can write this quadratic polynomial as x plus 5 times x plus 2, and therefore my zeros will be negative 5 and negative 2. So I can rename these zeros as alpha as negative 5 and beta as negative 2 according to the formula. So we need A, B, and C to substitute in the formula. So A, B, C, we can find it from the quadratic polynomial. So A being the coefficient of x squared, which is 1, B being the coefficient of x, which is positive 7, and C being the constant term, which is positive 10. So I'm going to replace this in the first formula, which is alpha plus beta equals to minus b by a. So substituting the values, I'm going to get it like this, right? So minus of 7 by 1. So minus 5 plus and minus, if you take the product, the answer is negative. So minus 7 by 1 is minus 7. So negative and negative, you have to add the numbers. So 5 and 2, you are going to add it, and the sign negative, you have to take it. So therefore, LHS and RHS are equal over here. So we just verified. So we have to verify the second formula as well, which is product of 0 equals to C by A. So alpha being negative 5, beta being negative 2. Put it in the brackets since both are in the product form. And C is equals to 10 and A is equals to 1. So minus and minus, if you take the product, the final answer is positive. 5 and 2, if you take the product, it is 10. So 10 by 1 is 10. And therefore, again, this relation is also verified. So the next question, find the 0 of the polynomial x squared minus 3 and verify the relation between the zeros and the coefficients. So again, we have to do the same thing. So we have to find the 0 of this. We are going to equate it with 0 and x squared. I'm going to take the negative 3 to the right hand side, which will change the sign as positive 3. And I don't need a square, so I'm going to take the square to the other side, which will get me as root of 3 with the sign positive and negative. Therefore, the zeros are plus root 3 as well as minus root of 3, which I can name them as alpha being root of 3, beta being negative root of 3. Again, I need A, B, C. So A being the coefficient of x squared, which is 1, B being the coefficient of x, and since there is no x term in this question, so therefore we will consider the coefficient of x as 0 and c as the constant term, which is negative 3. So we will quickly substitute it in the formula. So minus b by a, so alpha s root of 3 plus beta s negative root of 3 minus of b value is 0, so a by 1. So root of 3 plus into minus is negative. So root of 3, 0 by 1, it is 0. So root 3 and root 3, it will be 0. So 0 is equals to 0. So the second one is alpha times beta equals to c by a. So alpha is root of 3, beta is minus root of 3, c is equals to negative 3 by 1. So root of 3 and root of 3, if you take the product, it will be root of 3 whole square with the sign plus and minus is minus, which is equals to minus 3 by 1 is minus 3. So square and the root will get cancelled. So final answer is minus 3 is equals to minus 3. So again in here it is verified. So the last example, we have to find the quadratic polynomial, and we are given the sum and the product of zeros as minus 3 and 2, which means our alpha plus beta is equals to minus 3 and alpha into beta is equals to 2. And we are asked to find out the polynomials, a quadratic polynomial. So for that, we have a formula which is x squared minus alpha plus beta times x plus alpha beta. So we are just going to substitute the alpha plus beta and alpha into beta as the givens, which are minus 3 and 2 respectively. And therefore, the quadratic polynomial will be x squared minus alpha plus beta is minus 3 times x plus alpha times beta is 2, and hence x squared minus time minus is plus 3x plus 2 will be our quadratic polynomial. So with this, we are done with the examples of the polynomial chapter, and thank you so much.